Hello everyone, welcome back to my channel Task World. So today we'll be learning chapter 3 of grade 6 mathematics, which is playing with numbers. So let's begin the show without any further delays. Now, the topics we are going to learn in this video are factors and multiples, and in factors and multiples we are going to learn introduction to factors and multiples, properties of factors and multiples, perfect numbers, even numbers and odd numbers, and common factors and multiples, and prime and composite numbers, and prime factorization. So let's start with introduction to factors and multiples. So now let's start with factors. Now, a factor of a number is an exact divisor of that number. In other words, a factor of a number which completely divides the number without leaving a remainder. Now, a factor of a number is an exact divisor. Means it will divide the number completely. Completely divides the number without leaving a remainder. Right. Now we have an example of 12. Now we can see the factors of 12 are 1, because 1 divides 12 completely, and 2 also divides, and 3 also divides, 4, 6, and 12 also divides, right? Now, in one table 12 will come. How? Let's see. So 1 into 12 is 12. So we can say 1 and 12 are factors of 12. So 1 and 12 are factors. Now, how is 2 divisible? By doing 2 into 6, which is 12 again. So 2 and 6 are factors of 12. So 2 and 6. And 3 is divided completely with 12 as 3 into 4. So 3 into 4 is 12. So 3 and 4 are factors of 12. So like this we found out the factors of 12. And let me tell you that factors of a number is not more than the given number. Like now, if we talk about 12. So first 12 into 1 is 12, right? And 12 into 2 is 24. So here we got 24. So we can't say the factors of 12 is 24. So 24 is not a factor of 12, right? So factors of a given number are lesser than the number. Now 24 comes in the tables of 12. So we can say 12 is a factor of 24, but 24 is not a factor of 12, right? So in one table 12 will come, so 1 is a factor. And 2, 3, 4, 6 comes in 12 table. They are divisible by 12. So they are factors of 12. So like this we find factors of a given number. Now let's start with multiples. So a multiple of a number is a number obtained by multiplying it by a natural number. Now here, as I said, if we start with 12 tables only, now 12 into 1 is 12. Okay. Now 12 into 2 is 24. And in the same way 12 into 3 is 36. Right. Now you can see here in 12 tables, 12 will come, 24 will come, 36 will come. There are more tables, right? So these are the multiples of 12, right? Now here. So these are the multiples. Now let's see other example. So we have 4. So 4 into 1 is 4, 4 into 2 is 8, 4 3 is 12, 4 times 4 is 16, and 4 times 5 is 20. So multiples are infinite. So now if the numbers are infinite, then multiples will also be infinite. So how we can say that? By saying, now if we talk about multiples of 3. So let's take multiples of 3. Now 3 into 1 is 3. So 3 is a multiple. Now 3 into 2 is 6. And 3 into 10 is 30. And 3 into 11 is 33. So whatever number we multiply it with 3, and then the product which we get as a result is a multiple of 3. So we can take any number and multiply it with 3, and that is the multiple of 3. Right? So numbers are infinite means multiples will also be infinite. So multiples of a given number is equal to that number, means the first step will be 3 into 1, right? Which is 3. So 3 is equal to 3, right? So 3 is a multiple of itself. So multiples can be equal or more than that number, but factors are lesser than that number or equal. This was about multiples. Now we'll start with properties of factors and multiples. Now let's start with the first property. 1 is a factor of every number. Now, if we talk about factors of 12, it is 1, 2, 3, 4, 6, and 12 itself. Right? So here 1 is also coming. So 1 will come in every number's factor. Not only 12's factors, it will come in every number's factors. So 1 is a factor of every number. You can take any number and list out their factors, but when you are listing out their factors, 1 will obviously be there. So 1 is a factor of every number. You can take any number. Now this is the first property. And the second property is every number is a factor of itself. Now, again let's take factors of 12. So 1, 2, 3, 4, 6 and 12 itself. Right. So here, as I said, 1 is a factor of every number. And the number itself is a factor of itself. Now, so 12 is divisible by itself only, right? So 12 is a factor of itself. Now, in 4 table, 4 will obviously come. So 4 is a factor of itself. And in 5 table, 5 will come, right? So 5 is a factor of itself. So every number is a factor of itself only. It will get divided easily. Now, if you see properties of division, if we divide the number itself, now if we divide 12 by 12 only, then we will get 1. So we are not getting any remainder, right? So if we divide the number itself by itself, then we will not get a remainder. We will get only 1, right? So every number can be a factor of itself because it's divisible by that number, right? Now we will start with property 3. So every factor of a number is an exact divisor of that number. Now as I said, if we see the factors of 12, if we take any factor and divide it with 12, then it's fully divisible. It's completely divisible. It will not give any remainder. Now let's see how. So let's take factors of 4. So 1, 2 and 4 itself. Now here, if we take 1, so 1 divided by 4 is 4. 4 divided by 2 is 2. So like this, if we take the factors of a given number and divide it, it will not give any remainder, right? So we can say every factor of a number is an exact divisor of the given number. Now the property 4 is every factor of a number is less than or equal to that number. Now as I said, factors are finite. So it's countable, right? Factors are finite. Means the factors will be lesser than the given number or equal to the number. Now again, if you write factors of 12, it is 1, 2, 3, 4, 6 and 12. Right. So it's only stopping at 12. It with 12 only. Now if you see the tables of 12, 24 will also come. So we can't write 24 in the factors of 12. It's the multiple, right? So factors is only till 12. So it will be equal to the number. So 12 is equal to 12. So factors will be equal and lesser, which is 1, 2, 3, 4, 6. So these are lesser than 12. So factors will be lesser or equal to the number. Now, the fifth property is factors of a given number are finite. Means what is finite? Finite means countable. So finite means countable. So we can count the factors. Now as I said, factors of a given number are less than or equal to the number. So the maximum is the number itself only, right? Then we can say factors is countable. So we can count them. So factors of a given number are finite, which is we can count them. Now, the sixth property is every multiple of a number is greater than or equal to number. Now, let's see multiples of 12. So, multiples of 12. Now, it is 12 into 1, which is 12, and 12 into 2 is 24, and 12 into 3 is 36, and so on, right? So multiples are, the 12's multiples is 12, 24 and 36. So not only these multiples, there are more multiples. So multiples are uncountable. They can be more, right? So every multiple is greater than or equal to that number, right? Now if you see the multiples of 12, it is 12, 24, 36 and so on, right? Now 12 is equal to 12, so multiples is equal to the number, right? And 24 and 36 are greater than 12, so multiples can be greater than the number. Now, so we can say multiples is greater or equal to the number, right? Now every number is a multiple of itself only. Now if we see multiples of 6, the first multiple will be 6 only. So if you start multiplying 6, 6 into 1 is 6, right? So 6 is a multiple of itself. 5 into 1 is 5. So 5 is a multiple of itself. So in 5 tables, 5 will obviously come. And in every table, the number itself will come always, right? So every number is a multiple of itself only. So these are the 7 properties of factors and multiples. Now let's start with perfect numbers, even numbers and odd numbers. Now what are even numbers? So all multiples of 2 are called as even numbers. Now 2, 4, 6, 8, 10, 12 and so on. So multiples are infinite, right? So on. So all these are even numbers because they are multiples of 2. So 2 into 1 is 2. So 2 is a multiple. And 2 into 2 is 4. So 4 is a multiple. And 2 into 10 is 12. So 12 is a multiple. So 2, 4 and 12, all these are even numbers. So these are multiples of 12, right? So these are even numbers. So all multiples of 2 are even numbers. Now let's start with odd numbers. So even numbers and odd numbers are just the opposite. So in even numbers, all the multiples of 2 are there. And in odd numbers, they are not the multiples. Now, if we see 1, 3, 5, 7, 9, all these are not multiples of 2. So they are odd numbers. So numbers which are not multiples of 2 are odd numbers. Now let's see what are perfect numbers. So if the sum of all the factors of a number is 2 times the number, then the number is called a perfect number. Now let's see an example. Now here we have 6. So what are the factors of 6? 1, 2, 3 and 6 itself. Now let's add the factors. So 1 plus 2 is 3 and 3 plus 3 is 6 and 6 plus 6 is 12. Now we got the sum as 12. So factors of 6, if we add them, the sum will be 12. And what is 12? 12 is 2 times 6. Means if we do 2 into 6, we will get 12. So 12 is 2 times the number 6, right? So sum of all factors of 6 is 2 into 6. Means it's 2 times 6. Hence 6 is a perfect number. So if we find the perfect number, so the answer of the sum of all the factors of that number is equal to 2 times the given number, then it's a perfect number. Now after adding these factors of 6, we got 12. And 12 is 2 times 6. So 6 is a perfect number. Now let's start with common factors and multiples. Now what are common factors? So when some numbers have the same factor, then that factor is known as the common factor. So find all the common factors of 12 and 30. Now here Here we should find all the common factors of 12 and 30. So here the name only suggests what is common factor? Common. So common means same and factors means the factor of a given number. We know what's factors. Now let's take an example to understand it better. So we have factors of 12 and 30. So factors of 12 are 1, 2, 3, 4, 6 and 12. And factors of 30 are 1, 2, 3, 5, 6, 10 and 30. So these are the factors of 30. Now let's see what is common. Now here 1 is common. So here 1 is common and 2 is common and 3 is common, right, and 6 is common. So what are the common numbers? It is 1, 2, 3 and 6. So these are the common factors. That's it. So these are common in 12 and 30. So we wrote down the factors of 12 and 30. So these are the factors. So 1, 2, 3 and 6 are factors. And these are common in 12 and 30. So these are common factors of 12 and 30. So like this we find common factors. Now we have coprime numbers. So when two numbers have only one as their common factor, then those two numbers are called coprime numbers. Now if we find factors and the common factor is only one, then that two numbers are coprime numbers. Now let's see factors of 4 and 15. Let's take an example. Now the factors of 4 are 1, 2 and 4. And factors of 15 are 1, 2, 3, 5. So the factors of 15 are 1, 3, 5 and 15. Right. Now 2 is not there. 2 and 4 are not there in 15. And 3, 5 and 15 are not there in 4. So these are not common. But 1 is common. Only 1 is common here. The factor is only 1. The common factor is 1. So hence 4 and 15 are called coprime numbers. Now if we see the same. So let's take factors of 4 and 17. Right. So let's see if these are coprime numbers or no. The factors of 4 are 1, 2 and 4. And for 17 it is 1 and 17 itself. So 2 and 4 are not there in 17 and 17 is not there in 4. Okay. Now only the common factor is only 1. So hence 4 and 17 are coprime numbers. So if the common factor is only 1, then they are called as coprime numbers. That's it. Now let's see common multiples. So when some numbers have the same multiple, then that multiple is known as the common multiple. Now find all the common multiples of 12 and 30. Now here we should find common multiples. So common factors and common multiples. Now here common factors means the same factor in both the numbers. Now it is multiples, right? The same multiple in both the numbers. Now let's again take 12 and 30. Now here we have the multiples of 12 and 30. Now let's see the common number. Now here if we see the common number, it is 60, right? So 60 is common. And at last here 120 is there. So 120 is common. Now if you find any other common multiples, there are no other common multiples, right? So only 60 and 120 are common. So these are common multiples. So the same multiples. So these are the same multiples of 12 and 30. So these are the common multiples of 12 and 30. Right. So this is common multiples. Now let's start with prime and composite numbers. Now what is a composite number? Now a number that has more than two factors is a composite number. Like if we talk about 8, 8 has 1, 2, 4 and 8. So these are the factors of 8. Now we know that 1 is a factor of every number. Now here it has more than two factors. So what are the two factors? It is 1 and itself. So it's 1 and itself, the number itself, right? So these are the two factors, right? So 1 is the two factors. It has more than two factors or no, we should check. So we can ignore 1 because it's a factor of every number, and 8 also. Now still if we ignore these also, we have 2 and 4. Then it is more than 1 and itself, right? Now if we count, we have 1, 2, 3 and 4. So 4 factors are there. So hence 8 is a composite number. So it has more than two factors. So what are the two factors? 1 and itself. So it has more than two factors, which is 1 and 8 here. So the remaining number is 2 and 4, right? So it has 4 factors. So hence it's a composite number. Now comes prime numbers. So prime numbers is just the opposite. A number that has only two factors, 1 itself and 1. And it's a prime number. Now here, if we talk about 7, 7 is prime number because the factors of 7 are 1 and 7. So these are the factors of 7. Now 1 and 7 are factors of 7, right? Now it has only two factors, which is itself and 1. So it has not more than that. So if we have 1, right? So it should have more than 2, right? So we can ignore 1 and 7 also because it's there in factors of every number, right? Itself and 1 are every factor. Now, if we ignore these, there are no factors. So we can say the factors is only 1 and 7. So itself and 1 are the factors of 7, right? Itself is 7 here and 1 is there. So it has not more than 1 and 7, right? So this is the prime number. So it doesn't have more than two factors. And the two factors are itself and 1. So this is a prime number. That's it. Now we have a special case of number 1. So the number 1 is not a prime and a composite number. Why? Because the number 1 only has one factor, not two different factors. Now, let's find factors of 1. Now, we know that 1 is a factor of every number. So we will write 1 here. And the number itself is a factor of itself only. So here it is 1. So again, we will write 1. So we are repeating a factor 2 times here in the list, right? So in the list, we should not repeat a factor 2 times. So we will ignore 1, right? So we have only 1. Now the factors is only 1. So factors of 1 is 1. That's it. So it doesn't have two different factors. So hence it's not a prime number or a composite number. It doesn't have a special name, right? So this is the special case of number 1. Only for 1 it happens, not for other numbers. Now let's start with the topic prime factorization. Now what is prime factorization? Any number can be written in the form of multiplication of their prime factors. So this is known as prime factorization. Now here we have 6. So 6 can be written as 2 into 3. Now we are using only prime numbers, right? 2 and 3 are only prime numbers. So here the name only suggests we are using prime. So prime means prime numbers. So all these are prime numbers, right? All these numbers are prime numbers. So we are prime factorizing 6. So it is 2 and 3, right? So 2 into 3 is 6. So it's equal to 2 into 3. So we should use only prime numbers while doing prime factorization. Now let's see prime factorization of 24. So we have 2 into 2, which is 4, and 4 into 2 is 8, and 8 into 3 is 24. So it's equal to 24, right? So this is prime factorization because we are using only 2 and 3. So we are using only prime numbers. So there is a prime factorization. Now this was about prime factorization. Now let's do only factorization of 24. So here we are not going to do prime factorization. We are only going to do factorization. Means we are not going to use only prime numbers. We can use composite numbers also. So then it's only factorization, not prime factorization. Now 24 can be written as 2 into 12. So here 12 is a composite number. So we can use any number, right? Because it's only factorization. So we can use any number. So 2 into 12 is 24. And the other factorization can be 2 into 2 into 6. So 2 into 2 is 4 and 4 into 6 is 24. So 24 can be written as 2 into 2 into 6. So here we are using composite number also. So we are only doing factorization, right? So no, we can use composite number also, but it should be equal to 24. Now 24 can also be written as 2 into 2, which is 4, and 4 into 2 is 8, and 8 into 3 is 24. So this is the factorization, and the other factorization is 4 into 6, which is 24, and we have 2 into 2 into 6, which is again 24. So we have again the same factorization here also, right? So these are the same factorization, and the other factorization is 3 into 8, which is 24. And here we have 3 into 2, which is 6, and 6 into 2 is 12. And we should do 12 into 2, and 12 into 2 is 24. So again, this is the other factorization. So these are the factorization. So these are not prime factorization, only factorization, because no prime numbers are there, right? So that's the reason. Now, prime factors can also be understood in the terms of factor tree. Now, what is factor tree? Like the branches are coming out. Like if we talk about 60, it can be written as 6 into 10, right? So which is 60. So again, 6 can be written as 2 into 3, and 10 can be written as 2 into 5. So we are branching out all the factors. So it's like a tree. So all the branches are So all the branches are coming out, right? So these are the factors. So we can also do it in factor tree method. So here only we will stop because we are not doing, so 2, 3, 2 and 5 are all prime numbers. So we will stop only till prime numbers. While doing factor tree, we will only stop till prime numbers. Now here we have the fact 2, 3, 2 and 5, right? So the factorization will be 2 into 2 into 3 into 5. So 2 into 2 is 4, 4 into 3 is 12, and 12 into 5 is 60. So we can do it in the other method. So 60 can be splitted as 2 into 30, and 2 is a prime number, so we will stop. And 30 can be written as 2 into 15. So again 2 is a prime number, so we will stop. And 15 can be written as 3 into 5. So we got all the prime numbers. So 2, 2 and 3 and 5 are all prime numbers, right? So we will stop only till this. So again we got 2 into 2 into 3 into 5, into 3 into 5. So again we will get the same numbers only, but it's a different method. So the factorization will be 2 into 2 into 3 into 5. So we can also write it as 2 square into 3 into 5. So what is 2 square? So if we write a number here and on top if we write 2, then it's square. So this is 3 square and this is 2 square. So what is square? The number is multiplying 2 times. Now if we write 2 square, then it's equal to 2 into 2. And if we write 3 square, then it's equal to 3 into 3. So that's the reason. Now it's just the short form. So writing 2 times is very difficult, right? So we will do it as 2 square. So it's even more shorter, right? And 3 and 5 are only coming once. So we will write 3 into 5 only. So it can also be written as 2 square into 3 into 5. Now, prime factors can also be understood in the terms of long division methods. Like, this is the long division method. Now, let's see 260 now. So 260 can be written as 2 into 130. So here also we'll take prime numbers. So we'll take small prime numbers. So 2 into 130 is 260 and 2 into 65 is 130, and 65 can be written as 5 into 13, and 13 can be written as 13 into 1. So this, we should do it till 1, right? So whatever numbers here we took, these are all factors. Right. Now 260 can be written as 2 into 2 again and into 5 into 13. So we will write all the numbers. So 2 into 2 into 5 into 13. So 2 2s are is 4 and 4 5s are is 20 and 20 into 13 is 260. So like this we can do it. So it can also be done as long division method or factor tree. So that's it for this video. Thank you for watching this video. If you like this video, please don't forget to like, share and subscribe my channel. Thank you.